We're going to use scipy.stats norm to calculate the probability for normal distribution. Scipy.stat norm is a sub-library of scipy.stats that is used to working with normal distribution. Scipy.stats norm provides a range of tools to work with normal distribution, including probability density function, cumulative distribution, and so on. It represents the following function: f of x, 1 over square root of 2 pi sigma e to the power negative x minus mu to the second power divided by 2 sigma squared. X is a random variable, mu is the mean of the distribution, and sigma is the standard deviation. Well, the norm object in scipy.stats basically represents this function. Consider the following case. A survey indicates that for each trip to supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed, and they are represented by a random variable like x. A shopper enters the store. You're going to find a probability that that shopper spends between 24 to 54 minutes in the store. Also find a probability that a random shopper spends more than 39 minutes in the store. From statistics point of view, when you're asking to find a probability between 24 to 54 minutes, you're basically finding this area below the normal curve. You can convert everything into z, or you can leave everything in x value. If you decide to convert everything into z, this is x minus mu divided by sigma. If you do the conversion, your z1 is negative 1.75 and your z2 is 0.75 from x to z. Then the probability that x is bounded between 24 minutes and 54 minutes is the same as finding the probabilities z is bounded between negative 1.75 and 0.75, which is going to be about 73%. Now let's take a look at our code. First of all, from scipy.stats import norm, what is it going to do? It's going to just import the norm function for you. So it helps to find a probability. Set the mean to be 45 minutes with standard deviation 12 minutes. Now, the lower bound and upper bound can be defined as 24 minutes and 54 minutes. Why we need that? Because we're going to use norm.cdf. This is basically saying that, hey, find a probability that x is bounded between 24 minutes and 54 minutes using the norm function, and it is cumulative density function. The upper bound comes first, then you have mean located at the center with scale, which is your standard deviation, minus the area to the left-hand side of the lower bound is norm.cdf, cumulative density function, the lower bound, and then mean and standard deviation, which is the scale. Basically, you're finding the area bounded between left-hand side of the upper bound and left-hand side of the lower bound. Norm.cdf upper bound, parameter log equals to mean and scale equals to standard deviation, calculates the probability that the shopper spends less than or equal to the upper bound minus minutes in the store. And norm.cdf lower bound calculates the probability that the shopper spends less than or equal to lower bound. Then by doing this subtraction, you find the probability that a shopper spends between lower bound and upper bound in the store, which is basically gives you 0.7333 or 73.33%. If you multiply this probability by the total number of people in the store, you get 147 shopper in the store. So that's how you can make decision how many people providing service to be available in the store. Now, if I ask you to find the probability that X is more than 39 minutes, you have the option to convert it into Z. Well, you have your X minus mean divided by standard deviation, which gives you negative 0.5, or you can keep it as X. The probability that X is more than 39 minutes is the same as probability that Z is more than negative 0.5, which is going to be 69.15%, which is basically the area to the right-hand side of 39. And if you multiply that by 200 shoppers, you get 138 shoppers to be in the store more than 39 minutes. Well, in using your Python first import norm from scipy.stats, then set the mean equals to 45 minutes, standard deviation 12, you need that for the scale. And then what I want you to do, I want you to specify the lower bound, which is going to be 39 minutes, because you're looking for the probability that people spend more than 39 minutes in the store. Now, what I want you to do, I want you to use the survival function SF. SF stands for survival function. The survival function Sx of a random variable like x is defined as the probability that x is more than the lowercase x. Basically, when you're writing norm.sf, this function calculates the survival function SF of the normal distribution. It represents the probability that the value drawn from the normal distribution is greater than the specific threshold. Very good. So since the threshold is equal to 39, we know that the x value is going to be 39. The mean is 45 minutes with standard deviation, which is 12 minutes. If you run the code, it gives you the exact same probability, 69.14%. So we went over different types of probability function for you. One of them was norm.cdf, and the other one is norm.sf. If I ask you to find a probability that x is more than a specific value, you can always use norm.sf. Make sure to have your threshold. If you're using z, convert this into z. So instead of 39, you're going to use your z value, and then the mean must be 0, standard deviation must be 1, and so on. So again, if you're using x value, you have to stick to the values that is defined for your original data set. But if you try to use z value, convert everything into z, mean must be 0, standard deviation must be equals to 1. Then again, you can multiply the probability by 200 to get the number of people who are going to stay in the store more than 39 minutes. Then you can make a decision about the number of people to hire to be in the store for that amount of time and provide service. You can also specify at which time of the day this happens. So you can make a schedule for the people who are hiring and who are staying in the store more precise and more accurate.